So this is my Minecraft world, and I need to build myself a house of diamond blocks. So right here I have 144 diamond blocks, and I'm going to build myself a house that is using the maximum volume of these blocks. I'll be building my house over here, and so of these diamond blocks, like I said, I need to have the maximum volume. So that's not being like the tallest house, not the thickest house, but the maximum volume on the inside. I'm going to use calculus and build my Minecraft house, because using calculus I'll find the maximum volume for the inside of the house. So we started with 144 diamond blocks, and we're making a cube house. So we need to know, of those 144 diamond blocks, what is the maximum volume that we'll have like inside the house. It's easy to do it if we assume that the base is a square, obviously, because it's a cube house. So the square house has a square bottom. So here's the square base, the foundation. So the length and the width are the same because it's a square, obviously. But there's also the height that we need to take into consideration. We have several variables here. X being the height and Y being the width and the length, because again, it's a square. Okay, so it can be visualized like this piece of paper. This is our base, or yeah, it's all our materials flat, okay? But we need to make walls out of it, right? But you have these extra little corner pieces, because when you try to put the walls together, like, it doesn't really work because you have these annoying little corners. So you have to cut those corners off. But you're not just going to cut it all willy-nilly. You got to make it precise to make sure you're getting the maximum volume. Okay, so here's what we get if we lay out all the 144 blocks in a 12 by 12 square. Here's the square base. And here are the corners that we got to chop off. So we can make like a dotted line to each corner, because that is where like it's gonna fold up. And we know it's a 12 by 12 because we have 144 blocks, we're making a square, so it's 12 and 12, it's gonna be completely flat. So here's an example of what it would look like for the corners. So we take out like 1, 2, 3, 4, there we go, there's a corner. Now I have a shape that looks like this. And so just this right here, and right here, and right here, and right here, these would be the walls that are gonna fold up. So here's one of our walls built up already. And so you just have to do that for the other walls to make it a box shape. So now we have this shape box, but it's not the maximum volume. Like, we can make it bigger. We can make it have more volume. So now we're gonna find out what are the dimensions that we can make the house to make it have the maximum volume. In order to cut out the corners, this is X, and X, and X, and X, and X, and X, and X. So side 1 is gonna be 12 minus XX, so 2X. And side 2 is obviously gonna be the same thing because the square, we went over this, remember? So it's gonna be 12 minus 2X again. But then the height, as we determined before, is just X. So the volume of the whole thing, normally when you're finding the volume of a cube, it's length times width times height. That's the same here. So it's height, which is just X, parentheses, the length and the width, which are the same thing because it's a square. So it's X times 12 minus 2X squared, because there's two sides. It's length and width. So a way we can figure out what the maximum volume is here's the volume thing as determined, but now we can graph it. So I use Desmos, but I also drew it here for you. So then we look at the point right there. I circled it. The point right there is the local or relative maximum. The one down here is the relative or local minimum, but that's not important. We don't need to know that for this problem. And at that local maximum point, the point is 2 and 128. So 2 being the height and 128 would be the volume. So now back to our drawing equation thing here. So we now know that X is 2. So we can plug in 2 into the equations for the side lengths and width, and we can get what the length and width is, because it's not 12, because we have to subtract the two x's, right? And the answer is 8. So the length and the width is 8 and the height is 2. Now here's a drawing of our Minecraft house. The length and width is 8 and the height is 2, which isn't a very ideal Minecraft house, because who wants a too high house? Like, that's just a bad house. But we wanted the maximum volume. We didn't want a quality house, we wanted maximum volume. Now we're throwing in more calculus. So this is the way to do it, like, faster? Question mark? Not really sure if it's faster. So anyway, we have the volume equation. It's the same, because it's the same problem. But now we can expand it, because it's squared. So it's x times 12 minus 2x times 12 minus 2x. So then you do like the FOIL method, and like, there's a lot of steps, just watch. So now we can find the derivative of that, which is y prime, means the derivative. So to do the derivative of this, you can use the power rule. Nx to the n minus 1. 144, there's only one x, so that x just subtracts itself, because it's 1 minus 1 is 0. So it's just 144 minus 96x, and you get that because it's 48x squared, so the 2 times 48 is 96, and then it's just x, just one x left, because it's an x, yeah, you know. And then it's 12x plus 12x squared, because the 3 times 4 is 12, and then 3 minus 1 is 2, so it's just x squared is left. Now we need to set it equal to 0, because we need to find x, we need to solve for x. Now, we need some more room. So here is the equation, and so in order to do this, we can either factor, or we can do the quadratic equation. I'm doing the quadratic formula for this one, which is x, it's right there, that's the quadratic formula. But we can divide all of it by 12, because all of it is divisible by 12. And we get x squared minus 8x plus 12 equals 0. Now we can do the quadratic formula on this. So x squared is a, 8x is b, and 12 is c. So then we plug it into the equation and simplify. And we get 8 plus or minus 4 over 2. So now we need to find the addition one and the subtraction one. And we get this. So the positive one, the adding one, the addition one, gave us 6, and the subtracting one gave us 2. Now remembering that we have the square base, right? Square, that's a circle, it's a square. So each side is 12 minus 2x. So if we plug in that 6 into the 12 minus 2x, 6 times 2 is 12, 12 minus 12 is 0. We can't have a side length of 0. So we know we can't use the 6. Test the 2, even though that's more likely going to be the 1. But you gotta test it anyway, just to be sure. And so you get 8. So therefore we now know that the length and width is 8 and the height is 2. Here's what our house would ultimately look like with the maximum volume on the inside. Of course, it's not the ideal Minecraft house, because who would build a house out of all one material? And it's also too high, so like, let's open and make a door here. Oops. Like, too high is not a good house height, but we're finding up maximum volume, not good looking house. So now all you have to do is put some housey stuff inside, like a bed, and then like an enchantment table or something. Why not? We could have chests. Let's get ourselves a double chest here, a jukebox, and a note block. Boom. What else do we need in our house? Some paintings to make it look a little less blue. There's a TV, sure. Let's get ourselves like a pet for this house. Oh wait, we also need a door. How could I forget the door? Let's get this door. Boom. There we go. Now let's get ourselves a pet. Pet bird, maybe? Maybe a dog. Here's a pet bird. Close the door so we don't want the bird to get out. There's our pet bird right there. There's our cat. There's our dog. Well, they look weird in this texture pack. Kind of creepy. Anyway, that's our maximum volume house. Right here, let's... Oh no, the cat escaped. Maybe we can get some like landscaping. There we go. There's some nice landscaping for our boring square house. There we go. it.